Subtopic 3, techniques of integration. You have 3 techniques: substitution, integration by parts, and another one, integral for partial fraction. So let's see together about the substitution method. Actually, you already learned it before, so maybe just some revision for you. So this is just some proving, which is the formula on how can we get to use the substitution method here. So let's just proceed. If you try to look at here, I just want to explain, which is we are going to change from the x term into the u term. Okay, just proceed to the example 2.6. So if you try to look at here, actually example 2.6 already have a solution. Example 2.6 is for question A. By looking over there, you will be having 2x plus 1 power of 5 respected to x. In this case, okay, what can you do for the integration? First, you must make sure can we integrate before we proceed to the substitution technique. So just some revise. Okay, so we're going to do some revision here. Let's say you are having this kind of question, x respected to x. If you want to integrate x respected to x automatically, not automatically, which is directly in the simplest one, you'll be getting x squared over with 2 plus with c. Is it right? So now let's say if you are having this kind of equation, which is this kind of function, which is 2x plus 1 power of 5. It is in the bracket, and outside the bracket will be having power of 5 here. So it will be a little bit hard for us to integrate directly. So what can you do? You can use a substitution method, which is you can okay, so we can let u, okay, this one, so we can let u is equal to 2x plus 1, and then by having du respected to x, so you'll be having 2 here. And then the next one, as I told you, for the substitution method, you are going to make it all the terms that you're having here, I mean the x terms, since it is respected to x, right? All the x terms here into the u terms. So you already let u is equal to 2x plus 1, so you make it into this one. Substitute u as a 2x plus 1, so u here of course power of 5. And what is your dx? Dx, we've got it from here, which is you will be having a du over with 2 is equal to dx. So du over with 2 is equal to dx, so you'll be having, you want to substitute the dx, right? So dx is du over 2, so put it here, du over with 2. So then the next one, what can you do? So this is 1 over 2 du actually, so you can put outside the 1 over 2 here, and then you'll be having u power of 5 respected to u. And then the next one, which is you are going to integrate u power of 5 respected to u, you'll be having 1 over 2, and here you will be having u power of 6 over with 6 here. And don't forget, we'll be having plus with, we'll be having plus with c here. So therefore, we haven't finished yet, of course. Okay, sorry, here we haven't finished yet. The conclusion is we'll be having u is 2x plus 1 just now, right? So you'll be having 2x plus 1 here, power of 6 over with 12 here, plus with c. So therefore, you already got the answer here. So that's for question A. As for question B, try to look over here. You'll be having 1 over square of 3x plus 4. So we are going to let 3x plus 4. Okay, if you're having any rational function, usually we are going to let our denominator as u. Okay, it will be the same way as question D. We are going to take the denominator as u here, and then we are going to have question C. Question C, if you try to look at here, we'll be having x e power of x squared. Okay, so let's just see it together. As for question A, you already explained. Okay, as for question B, as I told you, which is if you try to look at here, we'll be having integral of 1 over square of 3x plus 4 here respected to x. So by letting u is equal to 3x plus 4, so du will be equal to 3, and then we're going to have a 3 du dx here, right? So 3 here. And then the next one, what can you do? You are going to substitute into your integral by using u terms. So you'll be having, since you already let 3x plus 5 is u, so you'll be having 1 over square of u. And what is your dx? You can see it from here, so you can change it from here. You'll be having du over with 3 is equal to d x, so you'll be having du over with 3. So therefore, you can simplify here. 1 over 3 integral of what? So integral of u power of negative 1 over 2 respected to u. Okay, so then you can finish up everything here. So you will be having this one. So actually you can have it in this way lah, which is you can just have it this way, so 1/3 here, and then of course we'll be having u power of 1/2 over with 1/2 plus with c. So kalau kita nak selesaikan dia ni, which is what can we do? We can simplify this one. 1/3 is over there, and then which is u is already simplified. The u is 3x plus 4 just now, right? So 3x plus 4, and then we'll be having 2 there actually, right? Sort of it, and plus with c there. Okay, you already have the answer here. As for question C, you are given u is equal to x squared, and then if you try to look at here, we are going to derive du respected to x is equal to 2x here. So you can see it from here, you will be having this one. I already have a solution. As for question D, we are going to let our denominator as u, and then you can try to look over here. They already factor out the 2 outside, so I hope you can see here. They already factor out the 2 outside, so we can have in this form x plus 1, because you can see from here our numerator is x plus 1 dx, so we want it in that form. So x plus 1 dx is equal to d over 2, so dia dah masukkan, dia dah jadikan kepada d over 2 kat sini. So substitute into this one, integrate 1 over u du respected to u, you'll be having ln u. So at the end of it, so substitute again what is your u, and then let's proceed as for the next question. Okay, I'm sorry, which is we have exercise. I already have answers here. Just try to do it by your own there. Okay, please make sure you try it by your own. I already have books, right? Okay, so next we are going to see on the next technique. The next technique is when you are having 2 different functions in one equation. As example, when you are having ln x respected to x, ln x, maybe you'll be having only one function, okay, but still maybe if you want to try x ln x, okay, x ln x, which is actually x here is defined for the ln, and the x here is polynomial, okay, which is I'm going to explain right now, which is for the by parts. Okay, if you cannot solve the integral by using substitution technique, we are going to use by parts. Okay, for the by parts, there is 2 things that you must make sure you are clear about it, which is about the log-pad. Okay, what is log-pad? I'm going to explain. Log-pad is logarithm, polynomial. Okay, this is for exponential. Okay, exponential, polynomial here, and t is for trigonometry. And how can we use this one? So I'm going to explain later. And the next thing that you must remember about the by parts is the formula. The formula is what? Which is integral of u dv is equal to uv minus v du. Or you can have it in this way, which is you can have it in this way. U dv is equal to uv minus v du. This is important. You must make sure you are not going to forget this part. Forget this part if you want to solve your by parts. Okay. Before that, before we proceed with by parts, there is one thing that you must be clear. First, which is you must make sure the integral is easy to integrate, which is as an example, as I told you, if you want to integrate x respected to x just directly, you will be getting the answer, which is x squared over with 2 plus with c. So you already got the answer there. Next, if you cannot solve the integral, as an example, if you are having e power of 2x and then x dx, okay, maybe you can use substitution technique, okay, substitution technique. And then the next one, let's say if you are having a little bit hard, which is you cannot use substitution technique. Okay, now you cannot use your substitution technique, which is as an example, maybe you'll be having x squared and then ln x cubed here, okay, so respected to x. So you need to ask some help using the by parts because of what, since we're having 2 different functions. But it is not necessarily, tak semestinya when you're having 2 different functions, you are going to use by parts. Maybe you can check first using your substitution technique. Okay, so we are going to proceed using your by parts here. Already have answers and solution. I'm going to explain through that one. Okay, example 2.7. Okay, example 2.7 as for question A, given to you integral of x e power of x respected to x. If you try to look at here, we can use your by parts. Okay, maybe you can try to check. Can we use, okay, first you need to check. can we use a direct integral? Okay, direct integral senang ke tak? So kalau susah, proceed to the next step. We are going to use your substitution method. Substitution technique. Kalau mudah, if it is easy, just proceed using substitution technique. If you cannot solve using substitution technique, proceed to the by parts. Okay, usually for the by parts, we will be having two different functions. Okay, so if you try to look at here, we are going to use your log pad. Okay, I'm going to erase this one first. Okay, so what is log pad just now? Which is logarithm, polynomial, exponential, and trigonometry. Okay, first define in the equation here, in the integral here, what do we have? Which is, for the first one, we are having polynomial, and the second function, we are having exponential. Okay, already define that one. Next, after you know this is a polynomial, this is exponential. So next, look at our log pad. So it is in a sequence. So we are having polynomial and we are having exponential. So who's come first? Which is the first one who's come is the polynomial, right? So we are going to let u. Okay, so we are going to let u is equal to, in this case, polynomial yang datang dulu. Polynomial yang exponential kan? So polynomial yang datang dulu, which is you'll be having x. U is equal to x, and your dv is equal to e power of x respected to x. As for this one, for the dv, you must make sure you are not going to forget to put the integral function here. So then the next one, derive u respected to x, it will be equal to 1. And then you are going to have a du is equal to dx. Next, integrate your dv here, means you'll be having v. Actually, you are integrating 1 actually here. Okay, so since anything multiply with 1, you will be getting itself, right? So integrate e power of x here, you will be having e power of x. Of course, it will be plus with c, but in this case, still it is still in the process, so we just need to put the e power of x only. So then the next one, what can you do? Which is you are going to substitute into the formula. The formula that we have is integral of u dv is equal to uv minus v du. So in this case, for the u dv here is actually your quotient. It's over here. We already defined who is u, who is dv. So I'm just going to proceed who is uv. So define u is x here, and your v is e power of x, minus with integral of, and who is your v? V is e power of x, and who is your du? Du, you already got it here, which is dx. So then we haven't finished yet. As for this one, you're already done, so you cannot disturb with this one. So minus with integral of e power of x plus, e power of x respected to x. So you'll be having e power of x, and don't forget for this one plus with c. So therefore, you already got the answer here, which is you can simplify this one, e power of x, x minus 1 here plus with c. So you already got the answer. So I hope you are clear about this part. Okay, so let's proceed. Before that, just some additional. Okay, let's say having the same equation here, having the same question here, having the same integral, if you just change the terms, if you change the place of the function here, let's say you'll be having e power of x dx. Okay, we still have exponential, we still have polynomial. Okay, so this is exponential, this is polynomial. Still, the polynomial is still come first by using the log pad. So that's why we are going to let u is equal to your x here. So I hope this will explain on how can we use the log pad.